In this video, I'll talk about how can we find out area under normal probability distribution. In the first video, we talk about the normal probability distribution and family of normal probability distribution. And here uh, we'll discuss about how can we find it out using statistics and GS4 table. So first of all, standard normal distribution, assuming that has mean to be. Yes, this is the x-axis, x. So this is the x-axis. So we have areas. This is the areas. This is the areas, and we can say here is 0. And if our standard deviation is on, and in every cases, if we increase value go on, that will add standard deviation on standard deviation. This is 2 standard deviation. This is 3 standard deviation. When you get it. And at the same time, when we subtract standard deviation, something less than mean value, then minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation. That will be subtracted from mean value. So that will help us to find out our GS score. And GS score that will help us to find out GS score. And GS score will measure, if I see GS score measure the measure position, till the number of standard deviation a value is on the mean. That means measure of that measure position until the number of standard deviation as values is formed from the mean standard deviation. We can say make it easier to calculate areas of probabilities using a curve. Curve use করে আপনি এরিয়া কিংবা কত রয়েছে সেটা আইডেন্টিফাই করবেন। ফর এক্সাম্পল আপনার এখানে একটা এক্সাম্পল দেওয়া আছে average mass is 63 and standard deviation is 3.9. that means standard deviation 3.9 ভেরি করে থাকে এবং প্রত্যেকের average mass আছে 60. The probability of getting less than 58, you can find it out in areas, or you can also use for this in percentage form. So we can use this form, this formula to find out area. So here we can erase this. I can bring this formula from here. This is this formula there. From the formula we have given z equal to x. X is equal to we have values. So x is equal to the mean is 60. X is equal to 58 minus 63 63. You should get a second bracket here. By standard deviation is 3.9. 3.9. So, but using this formula, you can find out your GS score. So, GS score is GS score equal to, if we subtract this value from here, we'll find 58 minus 63 divided by 3.9. So our CS score is equal to minus 1.28. So we can use the curve to find the value and represent it. So this is our curve, normal distribution curve, and in normal distribution curve we have the shape. Means there's a peak and again. So this is the middle. This is the mean point of the curve. This is the main point of the curve. So this is basically your 60. So what is the probability that you will get less than 58? So in case of less than 58, your value is 1 point minus 1 point. So minus plus automatically, so you can set value curve. So 1.28. So we should use 1.28 for the Fibonacci to identify 1 point. To 1.2, 1.2, and you can go for 8. 3.7, 3.997. So our probability is 3.997. You can see here 1.2 and our value is 8. So we're going to use it 3.97. So it will be here statistical value. Will be minus 1.399. So what do we see here on the graph? We'll use it. So 0.3997. 997 is the percentage of area, and our z-score value is z minus equal to minus 1.28. So the probability of scoring less than that is 3.397, or you can say probability is 0.397 or 39.97%. This is the probability. Now, if a question desired, what is the probability that you will get more than because when you get something more than mean value, you have to talk it as something happening like more than 62. Below 60, you will say always says less than 60. So what is will be the value? The desired to get x value is more than, that means they have asked you get more than 65. So 65 is so z-score value will be, you can directly put the value here. We don't like to go for any type of formula. So 58, now it will be 65 minus 60 divided by 3.9. So the z-score value will be 2.39. That means 0.51512. So this is the z-square value. So this value will be here because it is right side. Point more than 58.59. So now we can go to now have a look at z-square value. 0.5 to 1. 0.5, 0.5, this is 0.5, 0.5, 1, 0.5, 1.950, 1.950. So this is here, 1.950. So suppose we can put below here. We can write z value is 0.512. So we will have 19.50. Famous point 19.50. So we can say the probability of getting more than 65 is 40. So probability is 0.1950 or 19.5%. This is the probability of getting more than 65. When something desired that your mean is given 63 and your standard deviation is 3.9, and the question is that somebody will get marks between 85 to 63. In that case, what will happen? In that case, you will do something. That is, you have to subtract higher value from lower value. So the possibility, sorry, we will add this value. The probability of getting such marks will be the probability of getting such marks will be you have to subtract higher from the probability of getting marks between 58 to 65 will be 0.397 minus 0.1950. So whatever the value will be, that will be the probability of getting marks between these two. So 0.397 minus 0.1950. So about 0.22047. This is the probability. So that will be 20 0.47. This is the probability of getting number between 55 to 62. This is all about Haugen, and this is the area under this probability distribution. So first things, we have area under probability distribution. In the first uh, first, uh, first requirement we had area under here. Second requirement we had under area under here. And in the third requirement we have area between these two. That means this area. This area will be our area under non-homogeneous distribution to get such number. So this is the three requirement that you may desire in requirement in any type of calculation when you go to calculate any probability in using non-homogeneous distribution graph.